Hello friends, welcome to this video on complex integration. It is about integration of complex numbers. In this part 1 video, we will see about the Cauchy fundamental theorem and the Cauchy integral formula and the Cauchy formula for derivatives. Come on, we will move on into the video. The first thing we are going to see is going to be Cauchy integral theorem, also stated as Cauchy fundamental theorem. So say suppose you are going to have a simple closed curve C. So a curve C which is going to be simple in the sense that there is no going to be overlapping of the curve. If f of z is going to be analytic and its derivative f dash of z is continuous at all the points on and inside the closed curve C, then what happens? When I integrate it along the integral, the value of the integral for the analytic function f of z dz turns out as 0. So, for a simple closed curve C, if f of z is analytic, then what happens? Integral over C, f of z dz turns out as 0. This is referred as Cauchy integral theorem or Cauchy fundamental theorem. Moving on, we have the Cauchy integral formula, which says that if f of z is analytic inside and on a simple closed curve C. So again, I have a simple closed curve C that encloses a simply connected region R. So this region inside, what I have over here, this region inside is going to be called as R for me. And in this region R, what happens? I have any point over here. So in this region R, I have a point called as A. Then what will be the value of the function at the point A? So I can estimate what is my f of A as 1 by 2 pi I integral over the curve C f of z by z minus A dz, where C is described in the anti-clockwise direction. What do you mean by anti-clockwise? The clock always rotates in this way. So when I am going to rotate in this way, this is called as anti-clockwise. So how do you measure? You measure the direction or the curve in the anti-clockwise direction. So from this Cauchy integral formula, the main point we can take is whenever we have been asked to evaluate integral over C f of z by z minus A dz, this can be obtained by taking the product of 2 pi I into f of A. Just cross multiply this 2 pi I to the opposite side. So the value of the integral can be obtained as 2 pi I into f of A. So this is going to be the formula which is going to be most practically applicable for solving our engineering problems. So we will keep this to our memory. Integral over C f of z by z minus A dz is 2 pi I times f of A. Now we can notice that z minus A is going to be of power 1. Not necessarily always we will be having power 1. So if I am going to have of order more than 1, then what happens? We move on to find the Cauchy integral formula for derivatives, which says that Fn of A, n standing for nth derivative. So what will be the nth derivative of A? Will be n factorial by 2 pi I integral over C f of z by z minus A power n plus 1. If it is n here, it is n plus 1 over here. So if I want the value of the integral f of z by z minus A power n plus 1, then what I'll have to do? Just cross multiply this to the opposite side. 2 pi I by n factorial will now become in the denominator with Fn of A, the nth derivative. So when the power or in the denominator is more than 1, I use the Cauchy integral formula for derivatives. So we have learned two formulas as of now. One is the general Cauchy integral formula which has the denominator power 1, and when it is going to be of power more than 1, then we go for Cauchy integral formula for derivative. Now the primary aim over here is to find the singular point. What is meant by a singular point? A point z0 at which the function f of z is not analytic. Okay, so what we are primarily looking at, this is going to be something where the function is going to be analytic. So we are concerned about the points where it is not analytic. So what are those points called as? The point at which the function is not analytic is referred as singular point. What do we call them as? We call them as singular point, or you can also refer it as singularity of f of z. At certain points, they are also referred by the name called as poles. P-O-L-E-S, poles. Poles and singular points are one and the same. But how to find the singularity of any given function? So to find the singularity of any given function f of z, what we need to do is equate the denominator to 0 and then you will have to solve for the variable z. So what we are going to do, primarily we are concerned at points which is not analytic, and how to get the points? These points are got by equating your denominator to 0. Say for example, we have to find the singularity of the function f of z is z plus 3 by z minus 1 into z plus 2. So what we need is singularity. How to get the singularity? Equate your denominator to 0. What is my denominator here? Z minus 1, z plus 2 equal to 0. So I have z minus 1 equal to 0, z plus 2 equal to 0. So this gives me z is equal to, on solving, 1, and this on solving gives z is equal to minus 2. So what are my singularities or what are my poles? My poles or singularities are nothing but z equal to 1 and z equal to minus 2. When you have the factor over here to be of power 1, that is z is equal to 1, which is got by z minus 1, you call this z equal to 1 as a simple pole, because what is going to be the power over here? Power is going to be 1. In case I had the denominator as z minus 1 the whole square, then what would I have got? This on equating to 0 would have given me z is equal to 1 comma 1. So the value z equal to 1 is not repeated just once, but it is repeated more number of time, in which case you call this as multiple pole. So what is going to be a multiple pole? A pole or a singularity that repeats more than once is called as a multiple pole. A simple pole is one that repeats only one time, and a multiple pole will be repeated more number of times. And in particularly, you can say this z is equal to 1 is going to be a pole of order 2. Okay, because number of times it repeats is going to be 2 times. So you call it as pole of order 2. Simple pole, in which case what will happen, is always a pole of order. What do you call the order as? It is only repeated once. So it is always a pole of order 1. So when you have it more number of times, then it becomes a multiple pole, and you refer according to the number of time it gets repeated as a pole of order n. Okay, so this is how we go or first solve the base step for any Cauchy formula by equating the denominator to 0 and getting the point at which the function is not analytic. That is, you call that points are singular points or singularity of f of z or poles. Plus you have also now seen what is meant by a simple pole and what is meant by a multiple pole. So just equate your denominator to 0 and solve. That will give you your simple pole. Now moving on, next we will try to see or evaluate integral over c e power minus z by z plus 1 dz, where c is going to be the circle, mod z is equal to 2 and mod z is equal to half. As we said, primarily the first point in any solvation will be obtaining the singular points. How to get your singular points? The singular points are got by equating the denominator to 0. So what happens over here? Z plus 1 equal to 0. So this gives me Z is equal to minus 1. So how many times is Z is repeated? It is repeated only one time. So you call Z is equal to minus 1 as a simple pole. So our first step in solving has been got. What is the second step is this Cauchy formula is valid only for the points or the point A that lies inside the curve C. What will happen if it lies outside the curve C? So for any point A that lies outside the curve C, then the value of the integral f of z dz will be vanishing or will become 0. So you cannot estimate the value of the function at the point that lies outside. So keep in mind, everything which you are going to find are valid only for a point that lies inside. When it lies outside, what will happen? Automatically the function will move towards 0. So we need to check whether this point which we have obtained, which is z is equal to minus 1, lies inside this curve or lies outside the curve. So plotting the boundary becomes important in any problem. So your second step after finding the singular point will be plotting of your boundary. Now we will say or take the first boundary. What is going to be my first boundary? Mod z equal to 2. What is mod z? Modulus of x plus I y equal to 2. So to remove this modulus, let me square on both sides. So what is the square or magnitude value of a complex number? It is root over x square plus y square. That is magnitude of an complex number a plus ib is root over real part square plus imaginary part square. When I say imaginary part, it is the number attached along with I and not with I itself. So it is a square plus b square the whole square root. So now x square plus y square is equal to 2. So from over here, what do I do is I square on both sides to get x square plus y square equal to 2 square. I suppose you can identify this with a very simple formula or a simple curve which you would have studied for a longer life of time. So what does this curve represent? This curve represents a circle with center 0, 0 and radius 2 units. Okay. So what does this represent? My first boundary is mod z is equal to 2. Represents a circle with center 0, 0 and radius equal to 2 units. Now let us plot the circle. This is going to be my circle C, which is going to be having a center. What is the center? Center is going to be 0, 0 and radius to be equal to 2 units. What do you mean by radius as 2 units? Whether you move towards the left, right, top or bottom, you will have to have 2 units measured. So circle with center 0, 0 and radius equal to 2 units. So my curve has been got. So what is my primary idea? To check whether the singular point, which is z equal to minus 1, lies inside my circle or the curve C, or does it lie outside? So what is going to be the point? Z equal to minus 1. So I have the pole to be equal to z equal to -1. So this means I have a real part and there is going to be no imaginary part for me. So how do you convert this as a coordinate? So my x comma y will be, what is there in the x part? It is -1. What is there in the imaginary part? It is going to be 0. So now I am going to take and plot this -1 comma 0. In x-axis, where is -1? Here. And where is going to be the point? 0. This is going to be my point called as x comma y, which is -1 comma 0. So is my pole z is equal to -1 lying inside the circle or outside the circle? Yes, we are right. It lies inside this circle. So will I be able to evaluate the value of the integral? Yes. So since the pole lies inside the circle, inside the curve C, we can evaluate the integral. Okay, so now we are going to evaluate the integral. So what was that we did in the first step? We computed the pole by equating the denominator to 0. What did we do in the second step? We tried plotting the given region for us or the curve for us. In the third step, what did we do? In step 3, we checked whether the given pole is going to lie inside or outside. If it lies inside, I can evaluate the integral. When it lies outside, what will happen? The value of the integral will become 0. So now I am ready for the computation of the integral over c e power minus z by z plus 1 into dz. So how to evaluate this integral? Now compare it with the Cauchy formula which we have learnt. What does a Cauchy formula say? Integral over c f of z by z minus a dz is 2 pi I times f of a. Now this question given to us is going to be evaluate this integral over c e power minus z by z plus 1 into dz. Now identify what is there in your numerator. This is my f of z. My f of z is e power minus z. What is there in the denominator? Z minus a. In place of z minus a, I have z plus 1. So what is going to be my a? A is minus 1. So I have the second quantity. What is there in the right hand side? This is nothing but 2 pi I times f of a. So I need f of minus 1. So what will I do? This is going to be 2 pi I times f of minus 1. So what is my f of z? F of z is e power minus z. So in this, if I am going to replace my z with minus 1, what will I have? I will be having this quantity called as e to the power of minus 1. So what will this now make it as? Minus of minus will become plus. So it will become e to the power of 1, which can be simply stated as e. So this gives me 2 pi I times f of minus 1's value, which is going to be e. So what is going to be the evaluation of the integral? C for mod z is equal to 2 for e power minus z by z plus 1 to dz. The value is going to be 2 pi I times e. Now let us move on to the second part of the problem. What is the second part of the problem? We want it for the circle mod z is equal to half. What is going to be mod z is equal to half? So we will see that in the second part. So we want mod z is equal to half. So I have this as x plus iy equal to half. So modulus is nothing but root over x square, real part square plus imaginary part square is equal to half. When I square on both sides, I have this as x square plus y square is equal to half the whole square. So this represents a circle with center 0, 0. And what is going to be the radius? Radius is going to be half units. So this represents a circle mod z is equal to half, where the center is going to be 0, 0 and the radius is going to be equal to half unit. Half is nothing but my 0.5. So mark 0.5 on all direction and connect it by the value of a compass, you get a circle of the format mod z is equal to half. Now what is going to be my pole? I'll have to check for my pole. What is my pole? Pole is z is equal to minus 1. Where do you think the pole z is equal to minus 1, which is going to be the point minus 1 comma 0 lie? So this is going to be 0, this is minus 0.5, minus 1 lies over here. So my point minus 1 comma 0 is going to be at this position. Can you tell me whether it is going to be inside the circle or outside the circle? Yes, you are right. The pole is going to lie outside the curve mod z is equal to half. So what will happen to the value of the integral f of z by, for the values that lies outside the curve, the value will automatically become equal to 0. Therefore, integral over c e power minus z by z plus 1 dz will become equal to 0 because the point lies outside the given boundary C, which is mod z is equal to half. Hence, we'll have to be very careful what is going to be the boundary. If the points or the poles lies inside the boundary, then we will have to estimate it using Cauchy integral formula. If it lies outside the boundary, then you can very well state it as it's outside and hence the value is 0. So, it's as easy as that. Please recollect and then try to solve more problems. Thank you.